Okay, so let us now proceed to annuity, and I will first discuss the simplest form, which is the ordinary annuity. Suppose you're planning to deposit a portion of your salary in a bank. So at the end of this month, so let's say you will deposit 10,000 to that bank. At the end of the second month, you will also deposit another 10,000 on the third, fourth, fifth, and on the sixth month. Suppose this bank is offering a 10% interest per month. How much money would you have at the end of the sixth month? Okay, so let's try to calculate that. First, of course, your first deposit, which is 10,000, will earn a certain amount of money. And this is the amount of money that will be accumulated for a total of 5 months. So you will have, using the future worth formula, we'll have the principal times 1.1 raised to the power of n. Our n here is equal to 5. So this is the amount accumulated by your first deposit. Your second deposit will accumulate this amount. Your third deposit, your fourth, fifth, and finally your sixth deposit. Your sixth deposit is the same 10,000 because it is just deposited just this morning. So it means that this amount of money will not earn an interest because you're going to withdraw it today. So let's try to calculate the total amount accumulated by all of these deposits at the end of the sixth month. So using your calculator, that is equal to 77,000. So we represent that line here, which means that all of these periodic deposits distributed to 6 months is equivalent to this amount of money at the end of the 6th month, 77,000. Okay, so calculating the future worth of all of that monthly deposit is actually tedious because you will be dealing all of these calculations. So we'll try to develop a simpler formula for that. Let's analyze that. For example, here, let us consider that you are depositing a certain amount at the end of each period. So let's say A. And then at the end of the second period, you deposit the same amount of A until the sixth period. So in the case of ordinary annuity, your cash flow should always start on the end of the first period, as you can observe here. Okay, so let's try to calculate the future amount of all of these deposits. So your first deposit, A, will be compounded for a total of 5 periods. And according to our formula, that will be equal to the principal, which is A, times 1 plus I raised to the power of number of periods, which is equal to 5 in this case. And your next deposit will be this one. The total number of periods will be 4, and so on until we have the last deposit, which is, in this case, is A. Now, in order to calculate the total of these deposits, observe that we have here A in the first term, we also have A in the second term, and up to the last term. So we can factor out the A out of this expression when we add these terms. That's why we have now A here. And for each of this term, we also have one factor on the first A. We have the factor 1 plus I on the second, and up to 1 plus I raised to the power of 5 on the last term. In this case, we have replaced our 1 plus I by our R for simplicity. Take note that our R here does not represent nominal rate. Instead, we just use this variable to simplify the expression 1 plus I. Our goal is to determine the sum of this expression inside the parentheses. Once we have that, then we have a simple formula for the future worth of the ordinary annuity. Okay, so this is our R, our S now. So we can calculate the value of S. First, we multiply both sides by R. And then, this is now the result after multiplying by R, your S. And then, we multiply the first S by a negative. We place that here and then we subtract that with R times S. And then we perform the operation. As you can see, for each of the term on RS, there is an equivalent term on the negative S. So we eliminate those terms, leaving only the following terms. So we'll have only R to the 6th here, and we only have negative 1 here. So we'll have R to the 6 minus 1. That is the value of RS minus S. So here we can now calculate for the value of your S. So the value of your S now is this value. Now substituting the original value of your R, which is 1 plus I, we can have this formula. So this is now the simplest formula for the future worth of an ordinary annuity. We simply showed how this formula is calculated using these steps. Anyway, just memorize this formula. Okay, now we have another type of formula here. Suppose we want to calculate the present worth of all of your deposits. So the first deposit, which is A, should have a present worth equal to this one. Recall for your formula for the present worth of a single payment. So we have here the future amount, which is in this case is A, divided by 1 plus I raised to the power of the period from that deposit, in this case is 1. And then next, the present worth of this deposit is equal to this formula, and so on and so forth. Okay, so let us now calculate the present worth of all of these deposits. So the present worth of all of these deposits will be equal to that formula. How did we arrive to that formula? I can show you a brief history of that. We can also calculate that formula using these procedures. First, we can calculate the future worth of all of these deposits, which is, we have shown that this is the future worth of all of the deposits. As you can observe now that this is already a single payment F. We have a formula for the relation between the principal and the single payment F using our future worth of the principal, which is this one. So we can replace now our F here by this expression. So replacing that with that expression, we have now eliminated the variable F, leaving only the P. So meaning we can now calculate the value of our P. So to calculate the value of your P, divide both expression by 1 plus I raised to the n, and we arrive to this one. Or our P as another form, which is the one I prefer, is this one. So this is the present worth of an ordinary annuity. Okay, let us consider the application of our formulas. Example number 11. How much money must you deposit today in an account earning 10% compounded annually so that you can withdraw 10,000 yearly for 6 years starting at the end of the first year? Okay, so this is our cash flow now. Let us consider A for 6 years starting at the end of the first year. Let's count that. This is 1, 2, 3, 4, 5, 6. That's our cash flow, and this is our formula for the present worth of the annuity. So how much money must you deposit today in the account? The amount of money to be deposited in the account is the present worth of all of these cash flows. So you deposit. The question here is the present worth. The interest is 10% compounded yearly. The annuity is 10,000 and the number of years is 6 years. Okay.